Hi, and welcome to the Seamless Blend, digital textile dialogues with Gabby and Jorgen. Our primary purpose is to educate and initiate discussions. The opinions expressed are solely our own and do not constitute professional advice or services. We invite contributions from our audience and maintain an open community on Discord. Hello, Gabby.
Hello.
How are you doing?
I'm good. I'm excited to be on our second live episode that's live streaming officially.
Yes.
We've told people
Welcome everyone that has joined in, if any. We try to make it a bit more public this time that we're doing this, and so this is the first time we're really doing it kind of live in this way, which is exciting.
Yes, so this episode is what do you mean there is gravity in 3D? So that was my idea, to basically sort of say, I didn't know we were going to have to deal with all these difficult things when we're making digital twins of physical materials. This is my comedic way of saying, all right, we've got quite a lot to think about, basically. So just as a reminder, we are specifically focusing on digital twins of physical fabrics. That's what we're doing in this podcast. So we've had a few responses about digital materials. You had a little survey, I think.
It's been interesting to hear what people are saying. So maybe we could start off briefly with that in the beginning, just to recap a little bit what kind of questions and feedback and things we've been getting. And it seems like overall, it's been like we've been getting a lot of really positive feedback. But it's good to maybe clarify also, as you've already said, we're talking about really digitizing physical fabrics, and that's also going to be important for this particular episode. And even going into that title that you've as you mentioned, it's like when we deal with physical fabrics, there's a lot of behavior in about how that fabric moves. If you hold it up in one hand or then it drapes in a particular way, there's certain visualization aspects of the material, how it reflects light and how you see color and all of these things. And so that's what we're really going to be talking a bit more about today, is just kind of what are these things, and how do we actually capture them, and how do we go from a physical fabric that we hold physically in front of us into a digital fabric we see on the screen. So hopefully we can clarify on a few of those things.
Well, this is something that we spoke about as well, of breaking it up into three parts. So you've got like the appearance, the behavior, and then the data. So I think it's traditional to think about the appearance of the material, and we're going to talk about the capture methods around that. The behavior of the material, what it actually does in 3D, like whether it responds the way we would expect that physical fabric to respond. And then the third thing, which we're both really, I think, keen to focus on as well, is the data around it. So not just like the kind of standard data, but any kind of like impact assessment data you can add into it, just to make digital assets valuable within our supply chain conversation, and adding value to all of those digital assets. They're not just a design asset, which is very easy to be like, oh, just give it to the designer over there, they'll be fine, they can work it out. It's actually thinking about how those assets are really valuable within the entire supply chain. First off, we're going to think about capture methods. I think you were going to give us a brief overview about capture methods before we think about all the different types.
Yes, we did talk about this. It's just also even like, recapping what we said is that capture methods, first of all, that we talk a bit about is this, like, how do we capture? And by capture methods, we also really talk about appearance, essentially how a material looks like how a fabric, like what do you see with your eyes when you look at a fabric? And what we see, like it's a very subjective experience. We know anything from, you could say, people might be colorblind and might see colors differently, or like this, we have a very different way of experiencing the world. So a big challenge is also like, how do we then capture a material, bring it in digitally, or create a digital version of it, and make sure that we all see the same thing and work with the same thing, especially like when we collaborate and share this. So capture methods is very much about how do we capture the appearance of a physical real world material. And there's some very established ways of doing that. One I think important concept to introduce from the beginning is what is, like, a lot of people might come across this term PBR, physical based rendering. These are kind of standards. We won't go so much into detail on that today, but these are standards that are used in the industry. And this PBR very often comes together with texture maps. And that's also something we're going to be referring to quite a lot today. texture maps are essentially, again, we won't go too technical, but are image files that each almost like reflect or showcase and highlight a certain aspect of the material. So, for example,
Yeah.
like, different maps have different properties or different uses in how we simulate or showcase like how a material looks digitally when you bring it into a 3D environment. So that
Yeah.
is really, like, I guess, like, it's important here also to think about, we try to not make it too conceptual, but think about light, like light source, where is the light coming from, how strong is the light, these things. It's very important to mention
Quite a
when
lot.
people bring this in.
I was just going to say, so quite a lot of this was really new to me when I was going from physical textiles or
Me too.
2D creation of textiles into 3D creation of textiles, because I wasn't trained in understanding that within a 3D environment, you have a light source, right? You're in a black void, black hole, if you want, until you put a light source into a 3D environment. So first of all, it was me understanding, okay, we have a light source, which then will shine light, and then there will be reflections at some point. And then what are you reflecting off? Are you reflecting into the wide world? Are you reflecting back into a studio box? So the maps became, I always end up calling them maps. I think of them like layers. If you use Photoshop, they're like layers in Photoshop. You have to, when you do the repeats for any of these materials, you have to tile them the same way we're used to tiling a physical fabric. So like for my brain, going from 2D to 3D, I was like, they have to be in repeat, they're reflecting light. And then the other thing it's thinking about, which we're not, again, we can maybe we'll go do a whole other podcast just on maps, but about like height and what happens to the map when you look across it on the side. Does it have height to it? Does it have little hairy bits? Does it have a displacement on it? So we're not going to deep dive into those maps today. And we've got gamers out there who can tell us all about shaders, and they are insanely experienced on those things. For us, this is what maps do we have available to us that we can, in the capture methods that we have available to use today, that are realistic for the time frame and the cost for the supply chain. That's what we're going to go into, really.
Good summary. So, as you say, like when we say capture methods, we're really talking about like, how do we create these maps? And I think you actually mentioned something that's really important, because this is something that like I had to learn also when I came into 3D. Is this almost like, and maybe just to clarify for anyone that wonders this about digital materials, is that 3D works in this way. In the physical world, we go outside and take a walk, and you come across an object like a rock or a piece of furniture or something, and they're made out of mass, like physical mass. But in the 3D world, when we talk about digital materials and these things, you essentially have a certain shape of, like, let's say, for example, like a chair. One element of 3D is like shaping the chair, and this is often referred to as like the mesh or the 3D. Like, we actually build the shape of the chair. And then the second thing that you then do is that you have to then texturize the chair, or you have to bring the materials into the picture. So I thought that was like, that was a big, like a little bit of a moment early on for me. Then I realized that that's how 3D works, is that, it's like clay. You mold the chair or the product, or, like whatever you're making, you mold it, and it becomes almost like this mesh. And then you have materials that you introduce to it, so that you can now suddenly, swap that chair from being a wooden chair to a metallic chair. Is coming down to the digital material that's applied to it. And this is also very essential to, I think, this, everything we talk about in this podcast in general. So just wanted to clarify that. So coming into then, like, how do we create this texture or this digital material and these maps? And I'm going to try to be a bit short on this, because we could probably go into, a separate episode on each of these maybe later on. But I have just thought of it as like 3 different lenses or boxes or perspective. Hopefully this is useful for someone else when, you can evaluate different technologies that are used to generate maps. I tend to try to think of them as like there's 3 distinct boxes that I put them into. And one is direct capture, where you're essentially kind of capturing the physical world around you. For example, very often using a camera. This is where photograph the world. Another one is something that's been coming up a lot more in the last year, and which is like AI, and you can also refer to it as approximation, which is where very often you have a reference image. Let's say, for example, like in a lot of cases, flatbed scanners are used. So you put your material into a flatbed scanner, and then you just get a very flat image of the material. And then with AI or this approximation, very often we then, synthetically, this is not a term that's used, like we synthetically generate the maps versus in direct capture, it's more about being able to generate it from the data that you've actually captured, rather than like synthesize them based on what you find
Yeah.
kind of have available in your database. And then we have this really interesting, and you actually told me something, I think it was last week, that after a conversation you had, where we keep learning more things. There's a third box, which is procedural texture generation. He's a bit like, almost like seemingly technical word when we now talk about them. But procedural is more like when you build a material, a digital material, from building blocks. For example, like in the physical world, you weave or knit most materials from yarn.
Yeah.
And in procedural texture generation, you could, for example, like, start with a yarn, define the yarn type and specifications of the yarn, and then like weave and knit. Lots of cool software in that space.
It's
Or
definitely the holy
yeah,
grail if we could ever get there. 100%.
yes.
Yeah.
The downside, as we've discussed also last week, was just how like it can become quite technical. Like you need to maybe almost be a bit of a textile engineer, or have some, like, you need to at least be quite technically interested to learn how to construct materials in this
Yeah.
way. And the way that at least I understand it, we would love to hear from other people out there, if you have other kind of interpretations. But one thing that I've come across also in very much like in the digital only fashion space, like gaming and metaverse and applications like digital only, is also procedural can often be
Yeah.
used for materials that are just generated digitally. Like, for example, like we've seen even last few years, like NFT fashion items, these things where someone's wearing a dress made out of fire. Like you couldn't
Yeah, of
reproduce
course.
that dress made out of fire, but that would be a bit of like a procedural
Exactly. Or any of the
approach.
videos we see where the yarns are kind of like knitting themselves together or weaving themselves and then unweaving themselves, or any of those points, I used to be very skeptical about procedural texture generation, if I'm honest. As a textile designer, as a weaver originally, I was like, well, if you've not got it from the original, it can't be right. I was very skeptical, if I'm honest. So I'm sure there's lots of people out there who are as well. But I know people who are doing really interesting work in substance. And then I've recently been introduced to people who are, I haven't met them all yet, so I can't give any names out, but people who are building the materials from the yarn up, and that yarn has the properties of physical yarn, which means that material in 3D will have the properties of that material in 3D. So that to me is super, super interesting. And I also feel that my skepticism should be thrown out the window, because it was from ignorance, I think, rather than knowledge, if I'm honest. I'm trying to be really honest about like where my skepticism was coming from. So I think procedural textual generation, it's out there. We can discuss it more. But maybe now, thinking about direct capture, you mentioned something about, well, what skills do you need to do these things? And that was quite interesting to me, because we do in Bureau, we do lots of direct capture.
Exactly.
We use Vizoo's scanner with the X-Text technology. We use Bandicoot's technology as well. And so that's a lot of direct capture. So it's like, what skills do you need? Who do you need to be? Can you pick this up easily? And from an experience point of view, if you understand textiles and graphics, these are systems that you can pick up, right? We shouldn't be scared of them. If you understand repeats, if you understand tiling, Photoshop layers, lots of those things, then that knowledge can just be taken sideways into the different direct capture methods. So I think we shouldn't be too scared of them, if I'm honest.
No.
Are there any other ones that you wanted to mention within direct capture?
It's well, you mentioned, I think, of course, also like the different alternatives with and like but we say, but direct capture is very often involving a camera. So you need a camera. For example, like with a Vizoo, you have the X-Tex, the machine, the fabric scanner, where you have a camera on top. You have a box and you slide your fabric in. With Bandicoot, is essentially a frame, and then you have a handheld camera with a flash on, and then it's just a different approach to the same kind of process. I think in that space, I think previously we've seen a lot of use of X-Rite. Have had a machine called the Tax 7, or still have a machine called the Tax 7. It's been rather quite expensive, and my understanding is that machine was created really for kind of paint or coat painting on cars, and to be able to like
It's
really
a
capture that
circular
reflective.
system.
Yeah, yeah,
Yeah. I think we're not here to kind of go within the like the pros and cons of like selling you one of these
no,
direct capture methodologies. I just want to be really, really clear. I know what I've used. I've seen videos of the Tax 7. I've not used it. It's out of my it's
me
out of
neither.
my region for pricing.
Yes, out of my pay grade.
But it's very much obviously out there within, you know, automotive and home as well. Thinking, I guess, about other methods, I've done some investigation into the AI and the
I'd love to hear about that.
the assisted ones as well. So this is my own personal explorations into VMOD fabric generator, which has been super interesting, which VMOD is part of Clo, if people are familiar. I'm sure you're familiar with Clo. And it was under beta testing. And there was a way of submitting your fabric. And through that, you could then essentially sort of disseminate the maps from just a flat image of that fabric. So that was using, I'm assuming, their libraries, their backend data to generate the maps from your image. That was one option. The other option is prompts, which was super interesting. So you could prompt the material, or you could prompt the generator to get the material you wanted. I had less success with the prompts, probably because I wasn't as good as prompting than I did with inputting an actual material. So that worked as a solution. I think it's quite well priced at the moment. Whether it stays well priced, I don't know. I'm not here to sell it. But it was very interesting around creating those maps and coming out for like the design ideas, very much so. Frontier Cool with the Epson scanner as well is very has been quite interesting. I haven't done a lot of research into them recently though, but we did some work previously. So it's understanding that there's so many avenues that people could go down for this direct capture, especially if you're really price conscious, right? I think because if you're offered an iPhone scanning version tomorrow, a lot of people are going to go for that as a starting point, right? Because that's what we've all got to hand. It needs to be easy, it needs to be scalable, it needs to be usable. So I think what we're going to see is that combination of that AI moving into direct capture. This is what I'm hoping we're going to see. I don't work at the technology company, but I can hope, right? So I could see in the future that we'll have a direct capture method that will then use AI to support that, to enhance, maybe adjust the maps if you then want to do adjustments afterwards, because just because you've made one material doesn't mean you're never going to want to generate that again or use that again. So I think the blending of AI into that direct capture method is going to open up lots of different things for us, if I'm honest.
Like you say, also, I think that's a really interesting point you made with, I guess I could say, it's like, I do work for a technology company, but this is not like I'm not a technologist. So this is like what I feel a big part of my job is trying to take really technical, scientific, concept. And I have to try to like figure out what's my version of it. That's like the non-technical version. And my understanding of a lot of like exactly what you talked about with direct capture and approximation is that, in order to have a database, or let's say a data set to reference, like for the AI and approximation to reference, a lot of that data is actually direct captured. Like you have to build up a database of materials that are captured according to almost like, classic direct capture methods. And then you digitize a reference image, often with a flatbed scanner. And then that image is then used to kind of reference this database. And there's lots of like, magic and AI and according to my, the way that I like to try to keep it simple. And then this magic happened where you reference this reference image that you then have against this data set, and then it generates or like synthesizes these texture maps based on that. So there is already an existing relationship between direct capture and approximation in that sense, and I think that that's just going to be something we'll see more and more of, is that we'll see bigger and bigger data sets of direct captured materials that can then be used to reference against these reference images using approximation or AI technology, so that they kind of go hand in hand.
Yeah, and I wonder if some of this we just won't need to worry about in 5 years' time. We won't need to worry so much about not the method, but how it's happening, because right now we're right in the weeds of everything, right? We're really kind of like trying to understand what's the best method, how can we blend it with this, can we get a workflow that works for us? But maybe in 5 years' time, there'll be those underpinned workflows that we won't have to worry about anymore. It's a bit like, we have Windows because we don't have to write code to open up. We don't have to write the code to do file open, because we have Windows or whatever system we have. So I wonder if it's going to become a bit like that. One can only hope for all of us in the textile world that it becomes a bit like that, where it will just, some of those pain points will be taken away, or some of that decision making will be taken away from us, because it will be like, these are the maps that we know need to exist, and then here's a really good way to create them, and for these types of materials, this is what you're going to use. Because on our side, right now, we'll use different capture methods depending on the material, because some come in better in other materials, and some, for example, if I need to do a 2 meter by 3 meter material, like a sari, for example, with some of the jamdanis we've done, I can't do that in many systems. I can do it in Bandicoot, which is great, but I can't do it in lots of other systems because I can't cut up a vintage sari down into tiny little squares and scan it. So that's just the reality of where we're going to go within the industry. You know, what method will we use for this capture method? What works best for this material? The fashion industry really likes to have a one size fits all. But again, it's a similar thing of like, you go to your lingerie factory to make your lingerie, and you go to your denim factory to make your denim. I don't think we're ever going to have everything through one system. I could be wrong. Maybe I will be proven wrong, which
no, I think we might have to have technology to help us, like, as, you know, intermediary to trying to distribute like the lingerie orders to the lingerie factory and the denim orders to the denim factory.
Maybe it'll just do it that way.
Not to make the lingerie in the denim factory and so forth, you know, like, I think that might people might come up with something that's a bit different. But I think maybe just to quickly recap, almost like, you know, direct capture, the benefit, like the pros and cons is then essentially direct capture. You then need to have a device and a process, very often a camera, and these technologies are readily available. You can pick them up. They're quite easy to learn. They come at different price points, and the essence is essentially like you capture what you see using this device, and then you generate a material that is then accurate and true to life and kind of scientifically calibrated, that should be objectively, you know, a digital material that everyone can work with. Approximation is great because of speed, that you can do something very, very quickly. You can generate or synthesize the materials, but the downside is that it might not necessarily always be as accurate. This could improve with greater or better quality data sets and all these things. So that's just something, you know, like, where I think direct capture and approximation will go hand in hand. And procedural texture generation is fantastic, like you say, almost like the holy grail, in terms of like, you can really build a digital material up from almost like, you know, the components of like the yarn of the fabric, but at the same time, you might need much more technical expertise to go there. So, and also, like you mentioned, or I'd like, you know, let me fill in maybe if you you know, can add to that. But a lot of people might ask, you know, how do I decide which one is for me? And I think that it comes down to which angle you're coming from. Very often for companies, you have to define what your requirements are before you go into it, so that you can choose a technology accordingly. And then you have to understand just really what's important for you. And I don't know if you have any good examples of how you do this at Bureau, and how, you know, on your day-to-day you make these decisions.
It's kind of interesting. So we have a couple of companies that come to us with very clear workflows, and they know exactly what they want their workflow to be. They want it to be scanned through a certain type of system. They've set the resolution. It's going to either be in full color or grayscale. It's prepared in a certain way, and it goes straight into the PLN because that's defined and ready to go. But if we work with a fair number of small independents who are beginning to experiment in this area, and at that point we offer different solutions. So it could be that we offer a really like low cost solution for them as well, because different capture options cost different, obviously have different bands of cost. So depending on what the customer's requirement is around cost and time and efficiency, that's how we choose. We also look at, where's this material going to go? What software is it going into? If it's going into Clo and Browser, and its final render is in Clo and Browseware, that only renders it to a certain level. If it's being taken out, as in, sorry, I should make that really clear. Clo and Browseware will only render it to a certain level because it's staying within the Clo and or Browseware or Optitex or Style 3D ecosystem, right? If we're then going to take it out of that ecosystem and move it into, let's say, Unreal Engine or something else, we might have different requirements from our customer on what that actual map and materials have to be made from. We're not there really at that point. We're still kind of like rendering in Clo and Browseware with a bit of V-Ray, but that you can see that that's where it's going. So we've done a project with some people who are rendering our materials onto AI models, for example. That's really different for us because there's different render settings that we need to respond to. So it's understanding where's your fabric going, really. What's the cost that you can pay for it, and what sort of workflow do you want to work with the company? It's not clear yet. Like completely, there's not one way, that is what I would say. So we work with our customers quite closely to see what they really need, because we could go really in depth. And I use an example of like, am I going to take the Porsche to the corner shop, right? If I'm, if it's really, do I need to? Does it need to be super high quality just for what I'm going to do? So it depends what you're looking for.
And that's also where, like things can get very technical. So I think also that then you might require all sorts of different kind of technical levels of expertise to go into all these things. So that it's really helpful to work with someone that has done this before, or can like this. There's a lot of things there that you need to consider. So it's I think in particular in Bureau's case, is I always feel like if I have questions, then I can I know that you have experience with like across the board with many of these things, and it's really good to just have that input in the process.
Every day is a school day. We're learning every day. We're doing our best, and if we don't know, we'll investigate. I've just seen the time. We need to talk about physics quickly, because we were supposed to only be 30 minutes.
It's really hard. We had this goal of 30 minutes and it's very hard. But now, so now we talked about capture methods, apparents, the different methods to actually capture apparents and generate these maps. Another very, very important aspect of a digital material is the physics, like the way that it drapes in the real world. How do we, and this is, really almost like complicated stuff, but we're going to try to make it not so complicated. But like, how do you simulate the way that a material flaps in the wind, or whatever would be in the real world in a software? Maybe you have a good what is your simplest way of explaining that, Gabby?
Yes. Okay. So we're just going to ignore gaming for now. Okay. So all gaming people can be a little bit quiet for me, if that's okay, because essentially within the softwares that we're going into, we're basically looking at 4 key markers, which is bend, elongation, weight, and thickness. Those are the main things we look at. So bending, if any of those textile people out there, that's the Shirley stiffness tester. We're used to measuring like bending on our materials. It's not out of this world to do that. Elongation's the equivalent of tensile strength, except you're doing it warp, width, and bias for 3D. So again, if anyone's a bit worried about what does physics mean in 3D, these are actually standard tests that you can do with a textile testing house as well. So warp, width, and bias for bending. Then you've got your weight, which you generally get with your materials. That's quite good. And then thickness is just the micron tester, or the millimeter tester for the thickness. Then if you look at Browseware has stretch linearity as well, which is an extra method they have within their Browseware Fabric Analyzer, which is a really sort of stable way of testing your materials. I haven't used OptiText testing methods, and I haven't used Style 3D test methods, so I can only speak to Clone and Browseware right now. But essentially, these are the things you're thinking about: bending, elongation, weight, and thickness. And if you understand textiles, these are very understandable methods. So we have textile technologists in our company, and I sort of say to them, if I don't understand a report, can you look at them? And they're data people, they can just read them, they get it, even though they're talking about what it's doing in 3D rather than what it's doing physically. So that should hopefully give people some form of solace, I guess, to understand that it's not that difficult, right? And I think we do it in a couple of different ways. We do it with the machinery, the testing machinery, but then there's also databases that have been made. So Vizoo have got a PhysX database, which is populated by about 1,000 materials, over 1,000 materials now. So that's really useful. So it could be useful for people out there who are not wanting to test or don't have the bandwidth to test all their materials. There are databases that are being built up. There are paywalls, there are certain things around that, but they do exist. And I think as we go deeper into digital materials, that information will become more shareable, more collaborative. I think there'll be people who are working on sort of open source versions of that as well within the digital space. So that's quite a positive, I think, to note. And the last thing I want to say about testing is that we could just add a few points onto a fabric test report, and it would give you the information that you need for 3D, which we're already testing our materials anyway. I used to supply M&S, we had to test all their materials. So if you can do a fabric test report with just a couple more data points, you've essentially got all the testing that you need for 3D materials. And that's how we will make change in the industry, by just adding something simple onto a process that we're already doing. And then we can pull the data from it, we can use it in 3D, and we've got a reliable material that will actually drape and behave the way we expect it to. So that's my take. And I shall leave now.
Yeah, no, well, like we've said already, it's hard to really keep these conversations within half an hour. But I think it's the big question there again is also, as you mentioned, like you can use a device to capture this data specifically of the material, like you have the physical material. Very often these are destructive tests, so you're gonna have to like kind of cut up your material and actually like put them through a machine. It's the way you do like in a testing lab. I worked in textiles, textile mills, and textile mills have labs, and this is how they do their testing. So as you said, it could just be a part of the normal process, but 3D is still and these processes are still, again, they're, I would say, relatively new, and we're also lacking a bit of standardization in this space. So this is something we talked about, and almost like how should we talk about this? But one big challenge we have is this lack of a standard data set, and also a bit of lack of just like kind of a commonly standardized or accepted process of how you can maybe convert. Like if you have essentially the same, not the same data, but you have physics data, but captured for different purposes. You can't necessarily convert them between each other. This would be something I think very useful. And then of course the equipment used for this is also it's something that you might have to buy from, for example, like different vendors. And then that equipment can only capture data that can be used by one software, which makes it challenging for someone who, let's say wants to digitize a fabric, wants to get the appearance in a universal file format, wants to get the physics in a universal kind of standardized format. It's challenging because one physics capture method can only really digitize physics for one specific workflow or software suite. And that's just generally some of the challenges we have in that space.
I think you bring up a really good point. So there's the fact that we've got one software which uses a proprietary file format which doesn't speak to any other software, and then we have the other softwares which use an open file format which can be read visually anyway, but maybe not those data points. And all I can do is throw that back to the technology companies and say, please, for all of our sakes, can you talk to each other? That would be really helpful. I'm not the only person who's going to ask that, but that would be really helpful, because we are replicating data sets at this moment in time. So I might test it, I might receive a material through the door, and I might test it for one piece of software and then have to test it again for another piece of software because they don't read the same data points, which is frustrating for someone and for a business that's trying to become efficient and reduce textile waste and reduce waste in the supply chain, whether that waste is textile waste, energy waste, anything, labor waste, right?
Yeah.
We want to be able to be as efficient as possible. So that is a big hurdle at the moment. I will let the powers that be speak amongst themselves and decide if they want to go down that route. Then also, if we think about the hardware, if you have to purchase specific hardware from a company, hardware gets updated. We know hardware gets updated.
Oh yeah.
I work with, and then we're used to our iPhones getting updated. That's fine. We're okay. Every couple of years we'll update our iPhone. That's okay.
Yeah. You don't have to update.
You don't have. You could use it. You could continue using it. And if we think about a manufacturer like a textile mill, for example, they've invested, hundreds of thousands in a piece of machinery that can sit there for 20 years and work day in, day out. I've spoken to manufacturers who are like, but I just bought this piece of hardware and now I have to upgrade it, a year and a half later, because we're all moving forward quickly. So they feel a bit, this is a big generalized statement, but some of the manufacturers I've spoken to are a bit wary about investing in the hardware, because they're like, oh, it's going to be updated, and then I'll have a later model, an earlier model. So that is a bit of a worry. I can't solve that problem apart from saying, as long as we can be forwards compatible and backwards compatible into these pieces of hardware, then that would at least take away some of those pain points, I think, would be the main thing.
Yeah. No, I think this is, and even just to mention that, not mentioning anyone in particular, but these are also relatively, again, of course, maybe not against, a weaving loom or these things like, like the prices you pay for that, but we're talking about, $5, $6, $7, $8, $10,000, like, for this hardware. And so it's not just something that, an independent designer or studio would just purchase without really thinking about it. And then suddenly, like, it's one thing is the manufacturers thinking about, the downsides of having to, update this hardware all the time, but also
Yeah.
we're trying to make this with digital and just essentially to a lot of what we're talking about in general with 3D design, digital materials, and these digital processes. It's also just making it possible for anyone with, a laptop essentially to just
Yeah.
start to tap into this. And it's just creating a bit of a challenging situation for people on that side of the space.
Well, I think as well, considering, that if we think about maybe on the gaming side, where if you've got a powerful enough laptop, you can kind of like create insane assets essentially by yourself. Whereas we know at this point, we are still, with digital materials, we're still relying on external hardware to bring those things in. There's, there's no way around that right now. So we're still at that point. Should we just touch on the data side of it?
Yes, let's touch on the data and then maybe quickly just like recap a little bit more like how we bring all this together. And then I think we're going to have to, come back to this in the next episode again. It's there are probably so many things we could talk about, or we're trying to make it in, bite sizes. So let's talk about data. We had a big discussion about this because, people talk about metadata and people talk about master data. Do you want to have a quick recap of what we kind of
I'll probably get it wrong,
there?
though. That's the problem. I'm just like, are we talking about metadata? Are we talking about master data? As we understand it, metadata is data about data. So we want to talk about the master data, which is the data inside of it, which we think is really valuable and should be part of the digital asset. So yeah, we're going to talk about metadata and or master data. I'm still not sure.
Yeah.
So product data is the first thing we were kind of thinking about. All of our digital assets have product data around them. So you've got your technical data. So you've got your composition, your construction, your yarn counts, anything around the sort of like the construction of that material. Then you've got your sort of more business data needed for like the MOQ, the width, so minimum order quantity, the width, country of origin, the supplier, all the things that merchandisers need to be able to
and all these
lead
things.
time, everything they need to be able to fulfill the order, right? And then the final point, which isn't really being addressed at the moment in any systems we're looking at fully, is this traceability and transparency data, which will roll up into the impact data, which could then roll up into reporting for the ESPR European legislations that are coming in. That's products that are on the market in the EU by 2026 have to have digital product passports.
Yes, that's an episode in itself.
Yeah, we're not going to go down that route right now, but I think it's really important. It just makes sense. We are building files that are made out of data to add other data in the background, which will then go into whichever system you're using, into the PLM system. I'm actually about to do a project, hopefully, with Retraced, where we're looking at the digital asset, and then we have the impact data as well, and then that gets rolled up into the system, because we shouldn't consider these things separately. The designer working on the digital asset, the sustainability team working on the impact data, they have to be working together, otherwise we're never going to get there.
Yeah. No, I think there's a lot of untapped potential in this, and also maybe just to add to what you said, like the product data, the technical data about the material itself very often comes from the fabric mill. So at the moment right now, a fabric mill produces a technical data sheet. It's very common. And then if you get a sample of a material, you can even ask for a technical data sheet, or if you make an order for a material, you'll get a technical data sheet. And that material can be, or that data can be brought into this data container, and it can come together with these other aspects of the data we talked about with capture methods and physics. And then business data is coming from, also maybe from the fabric mill, where the fabric mill will tell you how much it costs per meter or yard. It will tell you what lead time it is and where it's produced and all these things. And then there's all of this impact data that very often, I think, the question that I often get, like when we have public conversations about this is, could we bake impact data into this, and could we just bring this in? Because then we would have a data container that the two other dimensions that we now talked about are, capture methods, which is appearance, talk about physics, which is kind of how it behaves. And then now we have this data on the side of it. That, imagine if you bring all this into this one data container, and then we do this from the fabric mill, because a lot of this is something we're probably going to be talking a bit more about later on. Where would you do a lot of these processes? A lot of them are done at the fabric mill already, but imagine if a fabric mill produces a fabric. And as that physical fabric comes off the the production at that factory, you can just bring it directly over into almost like a digitization center, or as it's currently done, just like bringing it over into the testing lab. You can do all these things. You can now build this digital twin, or this data set that kind of comes with it, and you have a physical fabric and a digital fabric, and you can then now let that digital fabric, that data container that you have there, you can let that travel together with the fabric. So you can take that data container, and then with a physical fabric, you can then give them to your garment factory, for example. Both of them, the garment factory would then construct a garment and do all the cut and sew and these things. They could maybe add more data into the container, so that then the garment would then be able to have certain information about it, and then you build a product passport, or however we wanted to, like different legislations will have different maybe names for it, or but you kind of build that from the bottom up. And I think this is something we're going to come back to later. So
building it from the bottom up, not retrospectively trying to get the information. And it's interesting you called it a data container, because we've not specifically spoken about this until this conversation right now, because we were going to let it lead it. So I've been calling it a data vessel, right? So that's exactly what it is. Like it's a container, it's a vessel, it's holding everything that we need, and building it from the ground up, as opposed to retrospectively trying to fit the information into it, which is where I want to be with making digital assets. Like literally put a stake in the ground on that one. That's where I think the future of it is.
Yes, 100%. And maybe we should even just almost like wrap it up on that's where we are at the current date, 20th of February right now, until we learn some more things, but I'm sure we'll start learning more things already tomorrow. But it's essentially a data vessel or a data container. And then within this, we have these 3 different elements, which are appearance, which we've talked about, and how you create that appearance. You have the physics, the data about behavior, and you have this master data, metadata elements that you bake all together, and then this becomes one file. And for the on a very low technical level, this could mean like on your computer, sometimes you might see a file that has .pdf, like that's a file, and within that PDF you have lots of text that is kind of under there, and that text can be read by humans by like opening it up, and this is just a file that maybe can be read by technology, or these things. So
exactly.
Yeah,
I think that's a great place to end it. I just wanted to mention that the next episode, which we're going to do on the 28th of Feb, is going to be called I Want to Get Started, But How? So we'll be looking at workflow, expertise, and the big topic of standards and integrations, which we sort of touched on today.
We did, I think so. For anyone that wants to understand a little bit more, like all these things that we just talked about, how do we actually get started doing it? We're going to talk more about that, and we have also, again, I'm going to refer quickly back to, we have a Discord community. If you have questions, sign up. The link is going to be, in the description or around here. We would love to hear, questions or things you don't understand, or feedback. And also we have a little survey. We would love to understand, how you that's listening to here, even if you don't even work with this, how do you define digital materials? Now, you've of course heard a little bit more about it, but we would love to hear just like, how would you define it? And we're trying to collect a lot of these definitions so that we can understand how different people see different digital materials, and then so that we can make sure we're clear and we're talking about it in an easy to understand way. So please, feel free to, there's no right and wrong answers. Everything is anonymous. Feel free to participate in the conversation on Discord, and tell us how you would define digital fabric.
Brilliant. Thanks a lot.
Yeah.
See you next time, people.
All right. See you next time.
Thank you for listening to The Seamless Blend. If you enjoyed today's discussion, feel free to subscribe. We also invite you to connect with us and participate in our discussions on Discord. Let us know if you agree, disagree, or have any questions. Until next time, take care.